Hello, everyone. Welcome to this video where we are going to discuss about database indexing in DBMS and why we need indexing and how it improves the performance of your queries. So without any further ado, let's start the video. So first of all, what is database indexing? Now, indexing is a data structure technique used to quickly locate and access data in a database. Now, as you are aware that when the records are stored in a file, they can be stored in any order. But when you are looking for some data, you may want to access the data arranged according to some particular order. Let's say I have a file which stores student roll number, name, address, and department. And the records are stored according to the roll number. But you would want to search the data based on the department. So in such a way, in such a situation, you might need to create something of a kind of a access path to the data so that the data, even though it is stored in the form of in the according to the order of the primary key, which is the roll number, you can access it with the department name. So this improves the speed of data retrieval operations. So if you have an index, just like you have in a book, okay, we have the topics listed out in an index. So you don't have to go through each and every page to find the topic you are interested in. You can directly look at the index, find the page number where of your interested topic, and then directly open that page. So it is the same concept here. And you have and separate, other than your database file, you have a separate file which is known as a index file, okay, where the entries in the file would be the field name or the field value based on which you are indexing and a pointer to the record of the actual file. So let's see this with the help of an example. Let's assume that I have my data is stored here. My records of the file are stored in the secondary disk like this. And now the data is stored according to the order of let's say the primary key, which is the roll number. So I have the roll numbers like this. So I have the roll number fields out here. So what we can have is kind of an index where I have a kind of an index such that if roll number is 1, then I will have a pointer which will say point to the location where this 1 is stored. Similarly, if there is 2, so I will have a pointer which will point to record number 2. Now this is at the record level. You may have something in a block level also, which we shall discuss in the next few slides. So what you see here, this is the index file. This is the index file. So this is your data file of records. This is also stored in secondary storage, as well as the index file is also stored in a secondary storage. So the index file has got two fields or two columns. First is the field value. So here I have the roll number, and here I have a pointer. I have a pointer either to the record or to the block where that record is stored. So this is what a database index is. So along with the data file, you will also now need to store a index file. Now these indexes can be categorized into either a dense index or a sparse index. In the previous diagram here, we saw that for every entry of the roll numbers, for every roll number, I have one pointer. So this pointer is pointing to the exact record where this data is stored. Now, I may also have a situation where my data is stored like this, again, same way, but I have blocks. It is divided into blocks. So I have roll number 1, 2, 3, and 4. Let's assume that this is in one block. and then this is 5, 6, 7, and 8. These are stored in the second block. Okay? And then this is my index. And here I have roll number 1. And now instead of pointing to the record, it will point to the block where that record is stored. Similarly, I may have something like this. So next block, the first starting record is roll number 5. So I have this pointing to the block containing roll number 5. So in the previous example, here, this is a dense index. This is a dense index because you have one entry in the index for each record in your data file. And this, whereas this you can see is known as a sparse index, where there is no entry for roll number 2, 3, 4 in your index. But you know that the data is sorted already in the according to the roll number. So you know that if you can get one, the next one would be 2. So here you have entries not for all the in the index you have entries only for certain records, not for each record. So such an index is known as a sparse index or non-dense index. Why do we need this indexing? As I have mentioned earlier, faster query processing. So when you want to see or you want to view the data sorted according to different fields, say department-wise or course-wise or roll number-wise or name-wise or address-wise also. In that case, for each of these, you can have a separate index. So this improves the query processing will become fast. Then also it minimizes the number of times you have to read the blocks and from your secondary storage to your primary storage, because you are not reading all the blocks one by one without an index. If you did not have an index, you would have to read all the records one by one to get to say this is number 7, let's say. So to get to 7, you have to bring all the blocks which comes before it. You have to read it to memory and then search through it. Then again, bring the next block, search through it, and so on. However, now with the index, you know that 7 is in where block 7 is stored, record with roll number 7 is stored, and you can fetch only that particular block. And it supports fast order by and where clause. So as mentioned, faster query processing. And for large databases where the number of files that you have, number of records that you have in your file is very, very large, in such a situation, index not becomes just an option, it becomes mandatory. Now, there are different ways in which we can categorize these indexes. So the basic categorization can be on primary. We have 3 types of indexes: primary index, secondary index, and clustering index. Let's start with the primary index. Okay. So primary index, the first point says that it is built on the primary key. So in every table, you will have a primary key. And here, to have a primary index, we assume that the data is sorted on the primary key. So if I take roll number example of our student file, in that case, the data must be sorted on the disk. It must be sorted on the roll number, which is the primary key. And you'll have each index entry is unique, hence non-dense. So here you can see this is an example which is taken from the Almasri Nawate book. So you can see this is your data file. And here you have the primary key field, which is name. In this case, we are assuming that the primary key field is name. So you have the name, which is unique. And the data is sorted according to the name. So you can see A, AB, AC, AD, and so on. Now, this is your index file. In the index file, what we have is we have the block anchor or primary key value. Block anchor, primary key value. Now, what is a block anchor? So here we are assuming that from this record to this record, this is block 1. From here to here, this is block 2, and so on. So each block now contains some number of records. So as you can see, in this index, we are keeping the first value of that block, of the primary key. So primary key is name. So the first name belonging to block 1, we have kept it here in the index. And then here there is a pointer pointing to this block. Second, we have Adams John. So here also you have, this is the pointer pointing to the second block. And in the second block, the first name is Adams John. Okay, so you can see the third one, Alexander Ed. Okay, so this should be the first name in the third block. So this is a pointer to the third block. And here we have Alexander Ed. So this is your index. This kind of an index, when we have, this is known as the primary index. So features we had, it was built on the primary key. The data has to be sorted according to the primary key. Each index entry is unique, so there's no repetition of values. So it is a non-dense index, or it's a sparse index. So what does it include? It includes one index entry for each block in the data file. One index entry for each block in the data file. So as you can see, we have for each entry, we have for each block, we have one entry in the index field. So if I have, let's assume that I have 1000 records, and there are in one block size is 10 records. In block, I have 10 records in each block. So I will have 100, 1000 divided by 10. So I will get 100 blocks. So in my index, I will have 100 entries, one entry per block. So this is a primary index. And the index entry has the key field value for the first record in the block, which is called the block anchor. So this is your primary index. Now coming to the next one, we have, other than the order in which the data is sorted in your file, you may also need to have certain secondary indexes. And these secondary indexes are created on non-primary key attributes. Okay, non-primary key attributes. So they are not the primary key attributes. So if name was the primary key in our example here, then I may want to sort the data according to, say, birth date or job or salary or anything like that. So the data file now is not sorted. Now data file is already sorted according to the primary key. So it is obvious that it cannot be sorted in two forms. So it is not sorted based on the non-primary key, whichever field we select. Duplicate values are allowed. Yes, if it is a non-primary key, then it is possible that they have duplicate values. So duplicate values are allowed in a secondary index. And then sometimes it is very useful for frequent queries on non-key attributes. So if our application requires that we access the data frequently on non-key attributes, arranged according to the non-key attributes, then we should go for the secondary index also. And here the index again is an ordered file with two fields. What is the first field? The first field is of the same data type as some non-ordering field of the data file, that is an indexing field. And the second field is either a block pointer or a record pointer. Let's see here. So again, this is also another diagram taken from the Al-Masri Nabati book. So here we are using a different field as the index field. So it is not named out here, but you can understand that this is a non-primary key field. So here you see 9, 5, 13, 8. It is not sorted. The data is not sorted according to this field. And also you can see some repetitions. Can you see some repetitions? Like here, I have, okay. Well, I can't find any repetitions. Okay, let's take this and see. So here I have, this is the key field. This is the index field. So in my index file, I will have the index value. So I have 1. And then from here, this is a pointer. This is pointing to the block where 1 is stored. So 1 is stored where? 1 is stored here. So there will be a pointer from here. If I follow this line, so this is a pointer to the block where 1 is stored. This is 2. So this is a pointer to the block where 2 is stored. So 2 is stored here. So I have a pointer to this. This is 3. So this is a pointer where 3 is stored. So in this manner, we can have a dense secondary key, secondary index file. So one point to note here that this is a dense index because you can see that for every value of that index field, like I have 1, 2, 3, 4, for each value of the index field, there is a pointer pointing to the block where that particular record appears. Okay, so this is a dense secondary index. We can also have non-dense also. Sometimes we may have a non-dense secondary index also. Then the third one is on the clustering index. Third type of index is the clustering index. This is also created on the non-primary key. So here, data is physically ordered based on this column, based on this key value, based on this index value. Okay. So, and what is the one index entry per group for each distinct value of the field. So here also I may have, since this is the non-primary key, I may have repetitions. So one index entry per group for each distinct value of the field. And the index entry points to the first data block that contains records with that field value. So if you look at this one, you can see here, department number, the data file now, you can see it is sorted on the index field. And what is the index field? The index field is the department number. Department number. So department number 1, department number 2, and so on, it is sorted. And here I have the index file. And in the index file, I have again two entries, two fields each entry. One is the value of the index field, and the other is a block pointer. So here I have one, that is department number 1. Where is the block where department number 1 is stored? So there is a pointer to this. And because the data is already sorted according to the department number, so I can just look up all the entries, go by, if I get this block, I will look up all the entries where the department number is 1. Okay. Similarly, you can see number 2, department number 2, this is a pointer. So this is also in the same block as 1. So we have a pointer to the same block. Similarly for 3, and I can go to 3, and 3 spans so many more across 2 blocks. So I have a pointer to the first one only. So it goes on like this. So here you have the index file. The index file will have one entry for each unique value of department number. So department number unique values are 1, 2, 3, 4, 5, 6, and 8. So I have one entry for each. So you can assume, you can understand that this is a non-dense index. Okay, so this is a clustering index. Why it is called clustering? Because the index value can have repetitions. It can have similar values, same values, multiple entries in the data file for the clustering index. So if I can go back here, okay. If we can go back and look at the primary, secondary, and clustering indexes. So first of all, for primary index, we use as the index field, we use the primary key. For secondary index and for clustering index, we can use any other non-key values. And for primary index, the data should be sorted according to the index field. For secondary index, the data need not be sorted. And for the clustering index, the data needs to be sorted according to the non-key field where we want. Then uniqueness required. Do the entries have to be unique? In case of primary index, definitely since it is based on the primary key. So each entry should be unique. However, for secondary and for clustering index, the data or the index field need not be sorted or need not be unique values. It may have duplicates. And the efficiency point of view, if we see primary key, of course, very, very high because it is unique, because it is based on the primary key and the data is already sorted. So you have high efficiency. For secondary and for medium, for secondary and clustering, for secondary it is medium because it can span across multiple blocks. So it may not be as efficient as primary key. Also, the data is not sorted in a particular order. So the efficiency may not be very high. And if you look at this, so you can see that if you are accessing record number 1 and then 2 and then 3, since the data is not sorted, to get 1, you have to go to this block. To get 2, you have to go to a different block. To get 3, again, you have to move to a different block. So each of these means a transfer from disk to memory, which is expensive. So that is why it is the secondary index, the efficiency is not that high. And finally, for clustering index, especially for group queries, when we want the queries where I want the data to be sorted according to some group, in that case, the efficiency is high because, as you can see, if I want for all values of department number 1, I can directly go make one access and then get the data, get the entire data. So for group queries, the efficiency is high. But for non-group queries, if it is single, if it is non-duplicate, then we should not go for clustering index. And finally, let's look at the advantages and limitations of indexing. Advantage, definitely our search becomes faster, queries becomes efficient, okay? And for large databases, it becomes very easy to look for data. However, the limitations are slower insert, update, delete. So some of the indexes, like you saw, primary and clustering, we need the data to be sorted according to the indexing field. So in that case, whenever we want to insert or delete or update, we have to first find out a place where it should be inserted. So if I already have a table with 3, 7, 9, okay, like this, data sorted according to this, and I want to make an insert for a value of 5, then I have to locate the position where I have to insert the record. And then it might require some shifting of the other records. So insert, delete, and update becomes slower. Also, you need extra disk space because you are now not only storing the index file, you use the data file, you also have to store the index file. So in such a situation, you need extra disk space for this. And because of so many multiple insert, deletes, and updates, your block addresses may keep on changing. So say, for example, okay. So here, suppose there is a new entry which is made for 3, it should appear here. It should appear in this block. Okay, so the block 4 will go and change, will move down. So there is another entry for 3. So this is replaced by 3, this is replaced by 3. So 4 will come down. So I have 5, all these will shift. So this, not only the data file will change, the index also will change. So for 3, which was pointing earlier to this, now will have to point to, for 4, sorry, if it was pointing earlier to this, now it will have to point to this one. So it needs maintenance from time to time. So this is in brief an introduction to your indexing concepts. And this is just a very brief introduction. And the final word is that even if there are certain limitations which are there, however, for a better query experience and better efficient search, it is always good to for uh, go for indexing. And it enables fast access. And there are three types, as we have discussed: primary, secondary, and clustering. What type of clustering you should use for your files? That you have to choose based on your application, your query patterns, and your data. Okay? It has to be customized according to your application and data. So that is all about clustering in DBMS in database systems. Thank you.